Good morning. We will be starting with the new topic in precast RCC, that is modular coordination. What is modular coordination then? Modular coordination is a concept of coordination of dimension and space in which buildings and components are dimensioned and positioned in terms of basic unit or a module. You must be knowing the idea or the concept of module in terms of design. You must have heard this word module while designing. So it is basically a standard element or a standard element you design, and then you keep on repeating that particular module again and again. Very similar concept in this construction. It is internationally accepted by International Standard Organization and many other countries. So the modular coordination was first explored as an aid to design shortly after the introduction of prefabrication in the construction industry. In the industrialization, it was conceived as further step in the development of systematic design and construction of building. So this subject has been discussed and attempted in actual building experiment in practically every developed countries. So how does it improves productivity? So through standardization, by promoting industrialization, as the components are manufactured in factory, and you have less wet work on site and non-dependence on unskilled labor, less modification on site, like that. So a module is a basic dimension which would, for example, form the basis of planning grid. We will see what planning grid is in terms of multiples and sub-multiples of standard module. So it also provide guide to building component sizing, reduce as much as possible the needs to further trim and shape the materials to fit together in construction, reduce wastage of labor and material. So aims of modular coordination: to achieve dimensional compatibility between buildings dimensions, making the planning simpler and clearer by a distinct indication of location of the building components in the building, both in respect to each other, a modular grid. Then you can say by simplification of site work, limiting the member sizes of the building components so that the linkage is based on modular measurement, reduce need to manufacture special sizes components, then facilitating cooperation between designers, manufacturers, suppliers and builders, providing practical and logical construction methods for the coordination of the position, dimension of elements, components, spaces in building design, which will contribute to first increased design features, increased design freedom, interchangeability of components. So you can say the logistics, to improve balance between quality and cost of manufacturing the component, and then creating a basis for rationalization of both general and special building drawings for modular building components and assembling details. So these all are the aims of modular coordination that are supposed to be achieved. Then the basics of module. What a basic module is? The basic module is known as 1M, which is equivalent to 100 mm. So you can say it as a 1 meter. 1M is equal to 100 mm. So there are three types of module: basic module, multi-module and a sub-module. So basic module is the fundamental unit of size in modular coordination, and for general application to the building and components, the size of basic module is taken as 100 mm and it is denoted by M. So whenever you see the modular coordination drawings, you will often see M written as a basic module. So it is considered to be large enough to affect some variety reduction in range of component size and small enough to provide a flexible unit of measurement for the purpose of design. Then multi-module. Multi-module is nothing but the multiples of the basic module. Certain whole multiples of basic module usually expressed in as M with numeric prefix as 2M, 3M, 4M, etc. That is referred as a multi-module. Then you have submodule. Certain submultiples of basic module, which are whole simple fractions, shall be chosen when absolutely necessary for increment smaller than basic modules for practical considerations. This submodular increment shall be expressed as m with fractional prefix 1 by 5m, 1 by 4m, 1 by 3m, something like that. Then you have the basics of modular reference system. So the term modular reference system is the three-dimensional system of orthogonal space coordinates within the positions and sizes of components, elements and installations can be related by reference to points, lines or planes. So I was talking about the figure at top right corner. You can see various orthogonal projections. Basically it is a modular space grid, a space grid in which a distance between consecutive parallel lines is the basic module or a multiple module. So there are it is also further subdivided, or other various components are like modular line, modular plane, modular zone, modular size, etc, etc. Okay. So basically it is divided into various modular lines, modular zones and controlling planes, you can say lines, zones and planes. So this thing you have to keep in mind. The figure in the bottom left you are seeing is basic modular grid. So what is modular grid actually? Plans, sections and elevations are expressed in 2 dimensions. So these are horizontal and vertical projections of a modular space grid. Different modular space grid may be superimposed on same plan or elevation for different purposes. So the advantages of using grids is that they provide a continuous reference system in a project, provided that the basic modular grid is kept uninterrupted throughout the building. The position of components and their corresponding modular dimensions can thus be recognized by those preparing the drawings and also by those reading them. So what is a basic modular grid? This is the smallest planning grid used as a basis for developing other grids. So the basic modular grid is normally shown only on small scale drawings to clarify the relationship between the components. So each square is 1m by 1m, that is 100 mm by 100 mm, as explained earlier, as a basic module. So these drawings are in the scales of 1:10 or 1:20, and they are also used in full scale detailed drawings. So this was about the basic modular grid. It is also subdivided into multi-modular grid also. Basically the modular grid is divided into 3 types: basic modular grid, multi-modular grid and tartan grid. So the image at the extreme right you are seeing is the tartan grid. Basic modular grid is on the extreme left. Then multi-modular grid you have, that is again subdivided into square grid and rectangular grid. So it is similar to the basic modular grid only. The multi-modular grid is formed with the intervals being multi-modules. They can either be squares with same intervals in both directions or rectangles. So this grid are based on the recommended multi-modules. They are used in key plans showing the layouts of buildings, complexes, buildings and position of main building components, and these drawings are usually have scales of 1:50 and above. Then the tartan grid. Tartan grid is an interrupted modular planning grid, which the intervals or bands of interruptions are regularly spaced in both directions and are of different modular order to the general modular planning grid, as shown in the figure on the extreme right bottom. This pattern may be used in very regular plans like those with columns at constant intervals throughout the floor. So the typical modular coordinated planning grid looks something like this, where the typical modular coordinated planning grid, M is equal to the standard module. So the very smallest square you can see is the basic module on this modular grid. Then you can see structural grid, which is used to locate the structural components such as beams and columns. You can see the structural grid shown as 45 into M. Then you can see planning grid, which is used for you can say based on any convenient modular multiple for regulating space requirements such as rooms, 9 into M as shown in the figure above. Then you can see the controlling grid based on any convenient modular multiples of locations of interval walls, partitions, etc. And then you have the basic model grid used for detailed location of components and fittings. So when you see it for the very first time, or when you study it for the very first time, it is little bit complex to understand, but slowly you will get familiar with this type of drawings. So typical modular coordinated planning grid, you have two main types, phase grid and axial grid. So phase planning and axial planning. So in phase planning, it is used to position components and elements of construction in relation to the grid. It determines both the positions and sizes of components and elements of construction. It also shows the relationship between different components. So it is represented by the pair of parallel lines, and the components or elements is placed with the faces on the lines. So the distance between the sets of parallel lines is always modular in phase planning, which is the you can see in the figure bottom left. Now regarding the figure on bottom right, it is axial grid or axial planning. You can say axial planning normally determines positions of major components, for example columns, cross walls, etc. So the grid lines in this plan will run along the central lines of the components. So the similar way you draw in the working drawing, grid lines in this plan will run along the central lines of the components, and the distance between the grid lines is always modular. So note the difference. In axial planning, the distance between the grid lines is always modular, and in the phase planning, the distance between the sets of parallel lines is always modular. Now these are several notations and standard symbols we used while working on modular coordination. So the very first representation is for modular line. You can see the circle and a line or a dotted line. Then you have modular space, that is distance between two modular lines. Then you can see modular line planning, then modular reference line and distance written in between them, location of reference line, then dimension lines. You can see reference plane, you can see checking dimensions, you can see modular dimensions, you can see non-modular dimensions, manufacturing dimensions, neutral zones for non-modular, etc., etc. So as you draw these modular coordination drawings, you will be getting familiar with this symbol. So at first this is really difficult to catch up or understand with this. Now the horizontal and vertical coordination. So the top left figure I have already explained in the horizontal planning. So the bottom right figure I will be explaining here. It is regarding vertical coordination. So the main vertical controlling dimensions are taken from coordinating planes in reference system, that is story height to floor height, floor to ceiling height, floor zone and roof zone. The intermediate controlling dimensions are also door head height, window head height, window sill height. So these types of dimensions are you can get the idea in the vertical coordination. The modular floor plane from which the vertical coordinating dimensions are taken is a continuous horizontal plane over the whole of each story of a building. This means that there is only one floor plane for each level. So this is really difficult to understand. Now these are some of the sample working drawings of modular coordination, wherein you can see the axial planning in this particular figure. You can see the modular lines, you can see the dimensions in numbers specified in mm. You can see how the dimension lines are given. Where the modules are not specified, you can see the actual dimensions written for the doors, for the windows, and so on. So this is one of the very simplest example of the modular drawing. This is the another example in which we are seeing the what you can say phase planning or the planning based on phase grid. So here too you can see the modular lines, non-modular zones, dimensions written, the dimensions for doors and windows. This is simplest example I have chosen just to understand how these drawings are made, how the basic drawings are made for modular coordination, and whatever the symbols we have gone through earlier. So as the level of complication in the drawings advances, all those symbols can be added gradually in this particular drawing. You can see the basic module as m, and wherever there is a repetitive dimension, you can see the prefixes added to the m, like n into 3m, whatever in the repetitive mode you are getting as a dimensions. This is just a part of a bigger drawing, just cropped to explain in this particular presentation. Now, in order to ensure that the modular coordination is effective in the design and planning of the building and all related building components, some guidelines are supposed to be followed. That is the use of recommended modular dimensions as much as possible. If not, then standardize the building components as much as possible. If this thing is too not possible, then for the building components that cannot be designed in modules or standardized, choose a dimension that is proportional to modular dimension and apply it consistently. Because when modular coordination is used, different parts of building will be perceived as components. So this include prefabricated components like doors and windows, as well as those put up during the construction such as floors, slabs and walls. The building process will then be seen as assembling of different components, and the influencing factors will be the position and sizes of the components and the tolerances allowed between them and their corresponding coordinating spaces. So the idea of the components will be therefore have to be conceived in early stages of design, as they will have bearing on the planning grids and approaches. So I hope you have understood the concept of modular coordination, the basics of modular coordination. This process can be well complex again as you introduce the other building components like stairs, partitions, claddings, windows, prefabricated toilets, etc. So the structural components are also added, more complex structural components. Then you can add finishes like ceiling finishes, floor finishes, etc. So this is how the basic of modular coordination is. We can have discussion regarding this if you need to clarify any difficulties.